In these last few examples in this lesson, we're going to determine if the triangles are right triangles using the converse of the Pythagorean theorem. So just to remind you what that is, I put the key ideas in here. If the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. All right, so let's look at A, which is the green one here. So if this is a right triangle, then we should be able to use Pythagorean theorem. So let's give it a try. It appears that if it is a right triangle, the angle that's between the side with the 9 and the 40 would be the right angle. Also, remember the legs always have the shorter lengths. So let's see if it works. 9 squared plus 40 squared. We're trying to find out if it's equal to 41 squared. So 9 squared is 81. 40 squared is 1600. And 41 squared is 1681. So if I add 1681 together, I get 1681, and it does equal 1681. So because they're equal, that means that yes, it is a right triangle. I can draw the little box here because I just proved that it is in fact a right triangle. So let's check B now. We're trying to determine if this is a right triangle. So we want to know, is this a right angle? So I'm going to take the lengths of the two shorter sides and I'm going to raise them to the second power. 18 squared plus 12 squared. We're trying to determine, is it equal to 24 squared? All right, 18 squared is 324. 12 squared is 144. 24 squared is 576. So now I'm going to add these two together, 324 and 144, and I got 468, which is not equal to 576. Since they're not equal, let me try to extend this page here. That is not a right triangle. We just proved that it's not using the converse of the Pythagorean theorem. The last two examples that we're going to do together are, we don't have a visual with them, we only have the numbers. Again, we're determining whether or not they are a right triangle. And some of you may be wondering, how do you know which ones are A and B, and how do you know which one is C? So if it is a right triangle, the legs are going to be the shorter side lengths. So that'd be the 14 and the 19. And this would be C. So if you look at this second one, the 1.4 and the 4.8 would be the legs, and the 5 would be the C, if it is a right triangle. So let's determine whether or not it is. So for A, I'm going to do 14 squared plus 19 squared. We're trying to determine, is that going to equal 23 squared? So with my calculator, 14 squared is 196. 19 squared is 361. And 23 squared is 529. So I'm going to add the 196 and the 361, and I got 557. That is not equal to 529. Therefore, This is not a right triangle. All right, last one. Again, the 1.4 and the 4.8 are going to be the legs if it is a right triangle, because those are the two shorter sides. So let's see if it is. 1.4 squared plus 4.8 squared. We're trying to determine if that equals 5 squared. So with my calculator, 1.4 squared is 1.96, or 1 and 96 hundredths. 4.8 squared is 23 and 4 hundredths. 5 squared is 25. So let's add the 1.96 and the 23.04. And I probably shouldn't even be using my calculator, but guess what? They are equal. Because they're equal, that means yes, it is a right triangle. I just proved it using the converse of the Pythagorean theorem.